All right, so we're given the function y equals radical 9 minus x squared over the interval -2 and 2. And we're going to revolve the curve of radical 9 minus x squared around about x-axis. Okay, so and we're going to get a shape like this, obviously. Three-dimensional picture. I'm going to show you what it looks like, in fact. Okay. And so let me show you what it looks like here. There we go. So we have the curve starting from here. We just revolve that, and we get this nice three-dimensional object. And you're interested in finding the surface area of this three-dimensional object. Okay. And here is the definition of the area of a surface of revolution. We have, in fact, two different formulas here. So please make sure that you have the right one to go with. We are given y as a function of x. So we're going to go with the first formula. And I'm going to try to utilize that. And r is sort of like the radius of the revolution. So here we go. I'm going to have a cross-section, a little cross-section here. And I'm going to revolve it around. So here we go. Let's say like I'm going to take this cross section and then I'm going to revolve it around. Let's say this is x units far from the origin. So now r of x corresponding to that is in fact the radius of the circle after the surface of revolution. Let's say like this circle is not a circle but a disk. With thickness dx. Okay, so r in this regard is determined by the function, which is radical 9 minus x squared. So I can go ahead and write this that this is 9 minus x squared. So I can now use the formula. So 2 pi times the radical 9 minus x squared. That's the circumference times the arc length, and times dx is in fact the area of the frustum after the surface of revolution of that little piece over there. And if we integrate it over -2 to 2, then we get the surface area. So at this moment, I need f prime of x. So let's just write that here. So f prime of x is, well, you have 9 minus x squared to the power of 1/2 instead of radical 1 minus x, 9 minus x squared, I'm sorry. So this should be like the power rule for differentiation, but the generalized version of that. So it's 1/2 9 minus x squared to the power of -1/2 times -2x. Okay. Let me just in fact write it clean. So I think you weren't able to see that one. Just write it here. F prime of x for f of x equals 9 minus x squared to the power of 1/2. That's 1/2 9 minus x squared to the power of -1/2 times -2x. And I'm going to rewrite this after I simplify the 2's. So we have -x divided by radical 9 minus x squared. Okay. I write this term as a reciprocal and use the fact that 1/2 power is the radical. Okay. So now I have f prime here, so I can go back to this formula and plug that back in. So this is another radical 1 plus the square of f prime. So that's going to be x squared divided by 9 minus x squared without the radical. Okay. Right, so I don't need this part, so I'm going to erase that. Let's try to simplify the integrand so that we convert that to something we can easily integrate. Okay. So this radical is fine, but the other radical, what I'm going to do here is that I'm going to replace 1 by 9 minus x squared divided by 9 minus x squared so that I have a common denominator now. And I can sort of like bring these two fractions together. So 9 minus x squared plus x squared divided by 9 minus x squared under one radical, right? There we go. This allows me to cancel x squares at the top. So you have radical 9 divided by 9 minus x squared, but that's the same as the radical of the top, the radical of the bottom, right? This is a nice trick, right? So we've got the common denominator inside the radical. So now I'm allowed to cancel this radical 9 minus x squared by this radical 9 minus x squared. Okay. All right, so what is this equal to? There we go. So 2 pi, you have radical 9, which is 3, so that makes it, in fact, 6 pi. Okay? 6 pi dx, and the integral is from -2 to 2. And if you integrate that, it's just 1. 1 dx integrated x, I'm sorry, from -2 to 2, that's going to be 4. So that makes it 24 pi. Okay? So if you go back to the three-dimensional object, and if you look at the surface area of that, is equal to 24 pi. All right. Well, that takes care of this question. Thanks for watching. I'll see you in another video. Bye.